Hi, I'm Karl Ashkar. I'm a graduate student at Cornell University studying material science and engineering. I'm here to talk to you about my research in metamaterials. More specifically, a new type of lens called a meta-lens and how it can revolutionize our day-to-day lives. Traditional glass lenses, typically made from silicon dioxide, are no strange occurrence in day-to-day life. They're commonly seen in various places such as microscopes, cameras, phones, telescopes, or any other device that may require some kind of visual processing. The general principles are more or less the same. A lens is simply a piece of glass that's shaped in a way that can change the way that light moves when it passes through it. It can either scatter light in many directions or focus it into one singular point. There's nothing particularly wrong with this, but a lot of the uses of modern-day lenses are limited by the materials used and the shape of the actual lens. That's where metamaterials come into play. So instead of using traditional glass lenses, we use electron beam lithography to write a pattern up the lens onto a silicon wafer. Metalenses are thin, flat, optical components that use nanostructures to focus the light. They're essentially the same type of lens as a traditional one and can perform all the basic abilities plus more and are orders of magnitude smaller. Metalenses are different than traditional lenses because they allow for better design of how we want the light to bend when passing through it. For example, light can only move in a set direction in a traditional lens, but by altering the material properties and the size of the nanostructures on the metalens, we have a lot more freedom of how we want the light to move. My job is to make these lenses using techniques such as electron beam lithography and reactive ion etching. We want our technology to be as small as possible. Metalenses have the potential to revolutionize the technological industry by rethinking the size and shape of our current electronics. Material science and engineering makes that possible.